Yeah, so I thought we could talk today about a little bit more about like mailbox storage. We've kind of been talking about it offline a little bit, and also maybe talk about the mailbox implementation itself, and potentially get to a point where we have something that can be incorporated either into the entity manager or the pod, depending on which component we're talking about. And to that end, maybe like a good starting point. Share my screen.
Yeah, maybe having a look at the current mailbox storage.
Well, I started like working on a little draw.io diagram because I felt like I was getting myself confused, and I thought this would be helpful to just start off looking at. Let me zoom in a little bit on this. So this is the structure of a pod that we discussed on stream the last time, um, where we obviously have a pod. Pod can have many shards, and then shards can contain entities, and shards are really just, we talked about this before, but shards are just an optimization for addressing purposes. But in reality, like the shard structure itself, like um isn't really like a physical component of the cluster. It's more of like an addressing optimization. But the pod and
Well, it is because there's a shard manager.
well, yes, but
It's not just,
the shard manager is on the cluster level. It's not on like the individual pod level.
yeah, but it is a component of the cluster who assigns shards to specific pods. So,
Yeah, I'm just saying like I'm talking about like things where code can physically live, if that makes sense, or things where code physically runs is what I was trying to like conceptualize in my head when I was doing this. So basically, like on the cluster level, and this isn't complete yet, but the idea was try to outline like some of the components we have running in the cluster and like talk about like where they actually live like on the cluster level. And I think Shardcake actually has a couple of nice diagrams related to this. But the shard manager lives on the cluster level. There's only one per cluster, and it has the ability to assign and unassign shards from pods. But if the shard manager goes down, there is still the ability for like normal cluster activity to take place. Like at least in Shardcake, the shard manager is not a quote unquote like everything is what's the word, durable in the sense that like if the shard manager goes down, the cluster can still operate relatively normally. Um,
yeah, everything keeps running. The only thing that cannot happen is when the shard manager goes down. If a pod goes down, those shards would not be reallocated.
right, because the other thing that and to that point, the other thing that the shard manager is in charge of is monitoring pod health through like an optional pod health API. But so that's like the cluster level components that I've outlined like so far. There's other things at this level, but if we take a look at like what I've started sketching out on the pod level, um, on the pod level, we have like the sharding component, which is what controls the actual communication between sharded entities. So sharding the sharding service, whatever you want to call it, lives on each pod and is responsible for actually like communicating between the different entities, whether they're local to the pod, like communicating between like entities between shards or even within the same shard, or communicating to entities on other pods. And there's one uh, there's one sharding service per pod, and yeah, that's basically like what the I mean, sharding does other things, but the main point of the service is to control communication. And then
Oh, by the way, just one point about the communication between the pod and the shard manager. You said that the shard manager is responsible for checking the health of the pod, but on the other side, if the pod cannot communicate with the shard manager for I don't know how long, there should be some kind of kill myself API, because the issue is split brains. What if a pod can't communicate, is disconnected from the shard manager and still has shards assigned? The shard manager will detect the pod as unhealthy and allocate the shards in other pods if a timeout occurs. Now, in that case, we have a duplication of entities. So it's very important that there is a kill switch mechanism if the pod can't communicate to the shard manager for longer than the timeout. Both the shard manager deallocates the shards, but also the pod stops stops the shards, because otherwise we have split brains
Yeah.
troubles.
Yeah, I mean, in Shard Cake, they actually talk about that. Let me pull up the little diagram because I was curious, basically, like similar to your what you bring up here. I was curious, like how Shard Cake handles this. Um, so let me switch tabs that I'm streaming. Um, so in the cluster here, the shard manager is uh, a single node in charge of maintaining the pod to shard assignments, and only one shard manager should be alive at a given time. The shard manager does have the ability to assign and unassign like shards from pods, and pods can register and unregister themselves or notify unhealthy pod to the shard manager. Um, if the shard manager the shard in shard cake, the shard manager is only involved when pods are added or removed from the cluster. That's the only time it's really involved. The rest of the time, the shard manager actually doesn't do anything. Since pods get a cached version of shard assignments and they communicate between themselves directly, so like uh, the pods read from the cluster storage directly to get assignments, and they have the ability to communicate with themselves um, directly to basically like take the shard manager out of the equation. So um, if a pod becomes unresponsive, for example, other pods would notify the shard manager, who would check if the with through the health API if the pod's still active, and it would unassign shards from the pod only if the pod's not alive. If the pod is alive, we can't reassign the shards because it might cause, like you said, the duplication. Um,
My point is, if you have a network split brain, there's no way for the shard manager to communicate to the pod.
right.
So it appears as the pod is not alive, but the pod thinks it's alive. That's the definition of a split brain on the network.
Yeah. So I guess your
So
point
this
is.
does not address my problem.
So your point is if the pod itself can't communicate with the shard manager, that we should have some sort of timeout where the pod kills
If the
itself?
pod thinks it's the pod thinks it's healthy,
Yeah,
okay, but the rest of the cluster can't communicate to the pod because there's a network failure, a partial network failure, which is the definition of a split brain.
right.
In that case, the cluster will reassign shards to a different pod, but that pod thinks it's alive. So the shards are its local cache, it's still fresh. Maybe it can even communicate to the outside of internet, just can't communicate to the pods. It's fundamental that the health API is kind of a central place. Let it be, for example, a shared database that we have anyway. I don't know, where each pod pings every pod seconds. And if the pod can't communicate its health, regardless, maybe the chart manager can go down, that's fine. But the health detection mechanism, it's fundamental that it is not based on simply a ping to the pod. Because if it's simply a ping to the pod, it's vulnerable to network partitioning. And network partitioning does happen. It's not a not situation. On the other side, if the pod unhealthy detection is like, I can't communicate to the database for more than, I don't know, 60 seconds, and by default I communicate every 15. I just increase a timer count in the database, like pod number and last
Yeah,
like
the
last
pod needs
heartbeat.
the pod
If the
almost
last heartbeat is,
the pod almost needs its own, like, liveness probe to, like, for itself, to, like, basically say, like,
yes,
"Can I
and
commu"
if that liveness probe fails, it needs to kill itself,
Right. Right, right. The
which
only
is the
pro
ring fencing mechanism.
Yeah. We'll have to figure out if the because if that pod kills itself and the shard manager would know that the pod would be down from the perspective of the rest of the cluster, so the cluster would already be rebalancing those shards. And yeah, so that would work. I was just thinking like how would the cluster storage update to like basically reflect the fact that rebalancing is occurring, but that already happens because the rest of the cluster can't see that pod, the pod can't see the rest of the cluster, so the pod would take itself down after whatever configurable liveness probe it has for itself, and the rest of the cluster would already probably be in the process of rebalancing. Okay.
Yeah, the only important point is that the pod has to kill itself faster than the cluster can detect its unavailability. Because if the pod can't communicate to the database for, I don't know, longer than 30 seconds, then it should stop all operations. Because it should assume some sort of network weakness is occurring. And of course, it could be that the database is down. So it could very well be that I need to stop everything and keep pinging the database. If the database comes back alive, I can restart operating normally. But the point is, the entities should be deallocated if uh, if the pod is unhealthy or cannot communicate its health.
Right,
At that point, the health API can simply be checking that timer and can say, I think the pod is unavailable if it hasn't sent a heartbeat to the database for longer than 45 seconds instead of 30. So you have this difference of time that guarantees that the pod kills itself faster than the shard manager can reallocate the shards.
right.
Because if the shard manager reallocates the shards faster than the pod kills itself, you have a ring fencing mechanism.
That could probably be like a configuration as well, and we could fail fast when the
Of course.
cluster starts. Like, basically, like, when the cluster starts, we could fail fast if, like, the configured, I don't know, pod liveness probe is longer than the cluster's liveness
Like
probe. We don't
consider that these cases only occur when there is either a network issue or a machine dies just out of the blue.
Right,
Because in the case of a graceful shutdown, the pod will communicate its unhealthiness directly, and the shard manager will automatically rebalance.
right,
So in a clean exit, we have fast recovery. The issue is when there is no clean exit, you don't really know if the point is, if you ping a machine, the only thing you can say is, if the machine is up for sure because it answers.
right,
But if the machine doesn't answer, you don't know if it's the network or if it's the machine. The server could be up,
right,
your
right, right,
network could be fucked up, your
right,
provider could have you know there's many different hops between you and the machine to know that, okay, a ping is failing doesn't mean the machine is down.
Right.
Sometimes it's up. It's just not responsive on the network. So this key element is very important if you have to guarantee that every entity only executes once,
Yeah,
because
that makes sense.
effectively the shard allocation is the reason why we guarantee that an entity only exists once in the cluster, because it's assigned to a shard, and a shard is uniquely assigned to a single pod.
Right.
But if the second part can be faulty, then we lose a critical guarantee.
Okay. I mean, that all
And if we don't have it, we need locking.
yeah, I'm tracking there. I think that makes sense. Okay, what else? So we talked about sharding, talked about the shard manager. We have entity managers on the pod level. So within a pod, there are entity managers that control like the life cycle of the individual entities, and there are, from what I understood, there are n entity managers per pod, which is equivalent to the number of distinct entities on that pod. So on this pod here, where we have users and to dos, there would be two entity managers, one for managing all of the users and one for managing the to dos. Um, what else? There's cluster
Those are
storage.
basically created when we register an entity.
Yeah, yeah, yeah. There's an entity manager that gets created behind the scenes when an entity is registered. The entity manager does a bunch of different things, um, but there's only one entity manager per entity type. Even though there might be like 100 entities of a given type, there's one manager for that entity. Cluster storage, I put this on the pod level, although it's technically cluster level, but like the actual service that communicates with the storage is on the pod level. So we could probably just move this to here, just for like sanity purposes. Um, on the pod level, there's also mailbox storage, which we discussed. I think we discussed it last time when we spoke. Um,
Yeah,
basically,
we sort of introduced the concept.
yeah, we've been discussing it offline a bunch as well, but basically, like the mailbox storage would be the on the pod level, the thing that actually writes mailbox state for each entity to some persistent storage, probably like within the cluster storage, and reads mailbox state from the external store, the persistent storage, when needed. Um, and then the on the entity level itself, every one of these entities gets a mailbox, which allows the entity to read incoming messages. And then the thing I did not put here yet was the behavior, which allows an entity to respond. Um, so this diagram is obviously not complete, but I wanted to start sketching out like some of the ideas and thing like assumptions I was making as I was working on cluster, since I'm still familiarizing myself with a lot of the components within cluster as I work to like redesign some of these things, and like kind of just refactor some of these things. Um, but anyways, I thought today we could try to focus on the mailbox storage and the mailbox itself if we end up getting somewhere with the storage that we're happy with. So offline, we've discussed a lot of the uh, aspects of mailbox storage, and like what it should look like, how it should function. So maybe I can pull up the code for that. Let me. Okay, share. I'm gonna try my text editor, and then we'll switch to my IDE if necessary. Okay, so
I like how your precision
I'm very
is on
careful with the way
point.
that I get very careful with the way that I talk about my editor with Mike. Let me zoom in. Mike, is this a good size?
Yeah, I think so.
Okay.
Yeah, this is good.
Um, okay, so uh we have been discussing, like I said, offline mailbox storage and what it should look like, etc. And one of the first things we started with was sort of sketching out what the actual table for mailbox storage should look like. Um, for now, we've sort of settled on something like this. But obviously this is not like final, so this is certainly uh, something that can change. But basically, we have this table that would be persisted in the cluster storage. Right now, this is written in like MySQL syntax, I guess. But we have this mailbox table, and the mailbox table has a bunch of different fields. So we have a field for the shard ID. We have a field for the entity identifier. We also have a field for the entity type. So the reason why there's a field for ID versus type is because if you recall, we can have multiple different identities, like user is the entity type, but then that user may be associated with like some identifier. It could be like anything. Um, so that's why we've separated the concept of the ID from the type here, because there can be many different entities of the same type within the cluster. Um, and then we have the message identifier. So messages as they come into the mailbox would have a unique identifier. And the primary key for this table is composed at the moment um, of the entity ID, the entity type, and the message ID. I remember we had a discussion in Discord about why the shard ID should be removed from the primary key, but I don't remember what the rationale was there. So this is one thing I want to talk about is like how we should key this storage and whether or not, I mean, first, like whether or not the fields that we have here actually make sense. And then we can talk about like how we're keying the table and things like that. But I'll go through the rest of the fields. The message body would be the actual like fields that the message is providing. So when you define like a tagged request that might have a bunch of different fields, eventually that message would be serialized and placed, that the full message body would be serialized and placed into this table. Um, we also have a field for whether or not the message was acknowledged. So at the moment, it's just a tiny integer or Boolean, whatever. And where 0 means that the message was just received, and 1 would indicate that the message was actually acknowledged. We've got the sequence number of the message. So Mike had brought up last time the concept of using a message sequence number to sort of allow us to have a cursor into where entities are in processing messages. So by using something like this, we can easily resume um, processing messages if, for example, an entity goes down or fails or whatever. We have like the ability to use a cursor to resume message processing, and this, it's very important that the cursor, this sequence number, be a monotonic sequence number that is um, scoped to the entity type and ID. So like within a given entity, the message sequence number would increment like for each message that entity receives. Um, the result of the message, actually, this should be not, well, the result of the message can be present, but it doesn't have to be because obviously the message could have been received but not processed yet. And this message result, similar to the body, would be the fully serialized like result of that message, using the tagged request to serialize that result. And then we have the keys here in the table. So um, the first thing I wanted to talk about is like, is there any other information that we need to track for mailbox storage? And then we can talk about like how we're keying this information and some of the queries that I've written to get information out of the mailbox. So so yeah.
I
Um,
I can't think of other elements that we should track there. I think at some point I raised um, a design trade-off. Let's put it this way. And the design trade-off is on the sequence number. Initially, I thought about a sequence number per entity, so it's monotonic increasing based on a single entity, and this would guarantee ordering of messages within a single within a single entity.
right.
Later on, I thought that the sequence number could be a sequence number per shard instead. The reasoning behind this is that whenever we spin up a new entity or we recover an existing entity from a new message, so let's say that we already processed all the messages for user 2,
Mhm.
but at some point we get a new message. So user 2 would not be allocated on a shard if there are no messages to be processed when the shard is allocated into a pod.
Right.
And um, that means when we receive a new message, the first thing we have to do is query the database to know, okay, what was the last sequence for user 2? Did it already exist? Did it not? And this is basically a read on what's called a read on write. Before writing a new message to the mailbox, you have to read to understand what was the what was the last thing. Now, this is not a huge problem because of course um, it's a single query. But if we think that messages are sporadic, then the entity would be passivated between T0 and T1, two different points in time. This read query is persistent. And we don't want to read all the entities upon restart of a pod because we might have billions of entities that are dead. An entity might live for 5 seconds and then no longer any purpose. Think, for example, an entity that tracks sending an email. Once the email is sent, that entity is gone. There's no reason why to restore the state of that entity in the shard that entity belongs to. So we don't want to query upon restart of a pod every entity. We only want to query entities that have messages to be processed. This is also to keep the initial query to a reasonable amount. You only have to fetch messages that have to be processed. You don't want to fetch the whole history.
Right.
The trade-off might be that if instead we have a sequence number per shard, upon allocation of a shard, we query from the database the last sequence number of the shard. And my argument there is because a shard is allocated to a single pod, generating the sequence number is a local operation, and all the writes can even be batched in the same, uh, or not, maybe not batched um, for duplication purposes because it has to error uh, if if it's already present. Maybe we can figure a way of batching the inserts potentially if we are slightly smarter with the query. But point being, the sequence numbers are generated locally, so it shouldn't be uh, problematic to do this. But Mattia then raised a different point, which is what if we reshard the cluster?
Right.
And resharding the cluster is an interesting point of discussion because and I guess it also then um, kind of has an impact in the discussion, should the shard ID be part of the primary key or not? Uh, because if we end up resharding the cluster, the entities will change the shard ID, because the shard ID is allocated based on the entity ID modulo the number of shards. So if we change the number of shards, each entity changes the entity ID. And this operation in my design with sequence numbers per uh, entity, per shard, would mean that we have to reindex all all the sequence numbers, which is an intensive operation. Whereas resharding, if we only store the shard ID, can be as simple as update all that has shard ID to X to Y. So it
Right.
can be done in a single query.
Right. Yeah, I mean, I think that makes sense. Also, um, so that kind of goes towards the argument of essentially having the sequence number per entity instead of per shard, right? Because if we reshard or rebalance the cluster and we move entities between, like we move a shard, around, or we rebalance an entity from one shard to another, um, yeah, it would be much easier to update the shard ID. So with this,
Yeah,
so with this primary
and
key,
and
essentially,
in this discussion, I think it would be even easier if we store the max number of shards in that table too, even though it's going to be a repetitive thing, but it would make the update query much easier, and it would make it so that we can do that uh, across multiple transactions.
and what would
Point being, yeah, go on. Sorry.
I know I was gonna say, if you could explain a little bit more, I'm not sure I understand why storing the max number of shards in the table would make sense.
Because if I think about how we go on about resharding, there has to be a database query which says, and that has to update every single message, okay? Which might be billions of rows if we consider history. And if we consider that you are resharding a cluster, which means you need probably more shards. There's no point in resharding a database to resharding a cluster to have less shards. Uh, it means you need more. Um, you're probably increasing the size, and you need more distribution. In that case, you need a query that sounds like update shard ID to two to one where shard ID was three,
Right.
because you're changing that number. Uh, Now, if you do that and you commit that, then you can't do another subsequent query which says update shard ID 3 to what was 2, because you've just changed the other one. Uh, You're
Right.
changing those numbers, and you don't have a selection. And instead, if you store the max numbers, you can say where shard ID equal 3 and max shards equal 512. That thing doesn't change, because when I update, I would change the shard ID, but I would also change the max shards. So the two queries don't conflict. Uh, to be clear, the cluster has to be down when this operation happens, but the difference is in the first one, I need to have everything in the same transaction and in the same statement. I can't afford, like, how do you keep selecting if you've changed the selector, like you have a part of the query which identifies which rows has to be changed. And that part, if you then change the information in that part, you might,
Yeah,
okay, what before was shard 1 now has become shard 3.
right,
But when you get to update shard 3, the row that you updated before, which was 1, now is 3.
right.
So how do you know that this was recently updated? You have to keep track of like the update number or some sort of thing. If you instead have the max shards, you can say, yes, I am updating shard number 3 with max shards count to 512. I'm updating that number to be 6 when and max shards to be 1048. So at the next query, I will select for shard 512, and my priorly updated row will not be part of the new update because it has the max number of shards changed. Which I
Well,
guess was the point that Mattia was trying to make.
I guess, but can we make the assumption that rebalancing only happens when you're expanding the cluster? Because like for example, in the current design, which is also I think the design in Shardcake. I'll actually share architecture again. Um, the current design of clusters rebalancing, I think, is the similar to Shardcakes, where rebalancing happens when the first pod registers, when a pod unregisters, or on a regular interval.
Rebalancing has nothing to do with resharding.
Does rebalancing doesn't rebalancing involve resharding in some cases?
No, absolutely not. Resharding means changing the numbers of shards. Rebalancing means changing the allocation of shards to pods.
Got it. Okay, then that was my
They are
misconception.
completely unrelated.
Got it. So resharding would be like if you need to move an entity between shards, or if you need to.
Let's say you start with 2 shards. Would be dumb, but it's a
Right,
free it's a free configuration. And you realize that if you have 4 pods and 2 shards, there's not much distribution that you can do.
right,
Or you realize that you have 128 shards, but you end up having too many users in the same shard. You then raise the number of shards to force entities to split more. This is obviously something that cannot occur when the cluster is alive because it changes the inherent structure of the cluster. It changes the allocation of entity to shard instead of the allocation of shard to pod.
right,
And entity to shard is something that can't change. If that changes, everything breaks. So you need to bring the cluster down, do resharding, and bring the cluster back up again. It would be like, I don't know, in a Kafka topic, you change the amount of partitions. Might move. Why would you change the amount of partitions? Well, if it's not performant enough. The counter argument is, why don't you start with 65,000 partitions? Well, because consumption could be more, takes more resources. So
right,
it's a balance. Now, if a well-planned cluster never needs to reshard, and there's not many arguments to have like less than some thousands of shards, I would set the default to something like, I don't know, 16K, something like that. So resharding is not a common operation, but it does put a bit of pressure onto the shard manager having to allocate 16K shards versus 12. It's much easier to just manage 12. So
Right.
if we are smart and we do things properly, then it's not a huge deal to manage a large number of shards. And probably resharding is a situation that will never present as necessary. But in case it it is necessary, then we have to change the messages, how the messages are stored. The alternative is we don't store the shard ID at all,
Well, that was gonna be
but
my
I'm
next question.
afraid then
That was gonna be my next question is, like, for the mailbox, do we need the shard ID? Because an entity is going to be.
when a pod
Yeah, go ahead,
when a
sorry.
pod comes up, when a pod comes up, the pod has to query the messages that has to process. How are those messages retrieved?
Right, it knows what entity it should go to,
Because
but it doesn't
pod
know.
only wants the entities for
Right,
yeah. The pod only knows which shards has assigned to. So the pod knows, okay, I need the entities that are in shard 1 and 5. This query can either be efficient if you query with with the shard ID indexed, then you get an efficient lookup. Otherwise, you have to query having the database compute the hash and compute the shard ID on the fly, which is possible, but it's a full table scan. I don't think we can assume that a database has hashed indexes. Some databases have hash indexes, and you could probably build some custom plugin that allows you to do that efficiently on a Postgres. But it's very database specific, and it's absolutely not portable across other other places. And there are databases like, for example, Cockroach that are very nice and very efficient. They have the same API as Postgres, the same protocol as Postgres, but they can be sharded themselves.
right,
And to shard themselves, they need some sort of shard identifier in the table that tells the database, look, all my queries will be within this shard. And if they don't, then it's less efficient because then you have distributed transactions, coordination between uh, mul- multiple registries, multiple main servers, each responsible for each shard, and so on and so forth. So I think the shard ID has to be stored for the query to be efficient in retrieving non-processed messages upon starting the thing.
right. Okay.
So that's
I think that, like, hearing all of this, um, to me, it makes more sense to go down the route of message sequence number being local to entity and trying to figure out the problems, solving the problems there, because I feel like message sequence number on the shard level, even though resharding should be a reasonably rare operation that we perform, we should still support it with, like, good performance, right? And if resharding is gonna be problematic, not problematic, but if it's gonna be a intensive operation, if we put the message sequence number on the shard level, then I feel like we should maybe try to figure out how to do this with the message sequence number local to the entity instead. Because the problem you were describing, so if we focus on that and talk about the problem that you were describing is that if the message sequence number is local to the entity, then restoring the state of a pod and its shards becomes, like, problematic, right? That was what you were talking about before, is like we may end up restoring the state of.
no, no, not Not specifically. What I said is it requires a read query before a write query to get the last message ID to generate the sequence number. But
But that
this
would only
doesn't even have to be necessarily true
I was gonna say because
because
that
we
would
have a query anyway.
when a pod when a pod starts up, it's gonna read the table, right? It's gonna get all the information about the shards that belong to that pod. Um, why would we need to do a read before every write if we can just store the message sequence number in memory when we're writing messages to the table? Like we get the initial reference to the last message sequence number, and we when we write the messages to the table, we just increment that message sequence number in memory. If the pod
No,
goes
we
down,
don't. We
if the
don't.
if the
We
pod, go ahead.
we don't. The reason is simple. When a pod starts, you only query the non-processed messages. You don't query the whole history of all entities
Yeah,
because you might have a billion of entities that are no longer alive. So you only query messages that have to be processed,
right,
which means you don't have the sequence numbers of all entities. You only have the sequence numbers of the entities that have messages, that have non processed messages. My point was if we instead make the sequence number per shard, then we can know it because we just need to query the shards instead of the entities. But this leads to other problems. Mm. The shard ID has to be stored in the message anyway, but the sequence number doesn't have to be related to the shard ID. My point was, do we relate the sequence number to the entity or to the shard? Both has pros and cons. But now that I think about it better, I see actually a potential issue uh, in in my design, which was a sequence number per shard. The potential issue I see is what if a malicious actor starts to send duplicated messages in the same shard? Well, we receive maybe 100 messages, of which one is duplicated, which it means the local sequence numbers will be fucked up because we then start to insert first, second, third, fourth. The fifth is duplicated. So the insert of the fifth doesn't go through, but it means six now becomes five, seven becomes six. So the whole local generation of sequence numbers is not a great idea. I think the better alternative would be that each message is independent and the query that writes the message also increments the sequence number, which is like the query you initially were designing, where you do select max from sequence number where entity ID equals current entity ID plus one.
and that
And
would
in
be
that same thing, if you have a duplicate, then it just fails, but the other query will insert the message.
and in that design is the sequence number is entity local, right?
Yes,
Yeah. So if we go actually to the code again,
which was the initial design, but I was kind of fooled into thinking we could save a read query
so if we
that we
ignore
don't need in the first place
we ignore all
because
my
the right query can read.
right, right. Here's my service. Um, okay. So let's ignore some of this. Let's go to the query where we actually insert a message. Um, Here's the query. So here we're doing an insert select. It doesn't have to be done this way because every database kind of has their own way of doing an insert statement where you don't want to do anything if you have duplicate messages. Um, so it doesn't have to be done this way. This was like a portable way to kind of do the insert. The I guess upsert's not the right way to 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 describe this query. It's more of like we're inserting, but on duplicate, don't do anything. So every database has its own kind of like method for handling this. I wrote a portable query for now, but we can always use the like SQL.undialect to write the like parlance for every individual database later if we want to do that. Um, but anyways, the idea here is that we're writing an insert select and we're selecting where not exists like the actual message. So basically we're saying like only insert these values to insert where we don't already have a value. But the
And
original,
also generate a progressive ID.
yeah, so now we have to add that piece in. So I think my original query was something like, all right, let's just assume for a moment that message sequence number is not in the request, even though it is right now. Um, select, I think I
If
wrote
you
like,
remove that,
I will, I will. Um, so can't remember what my query was before, but something like select.
it's like selects max sequence number from. You got the from wrong in the query that you posted, so I wouldn't just copy the query
Oh,
that you posted.
I'm not. I'm not.
No, the from was right. Was the where was not correct.
We want the where it's entity local, so we want it to be at least this.
Where entity type? Yes, that's the point.
Oops. So we want it to be entity local. Select the max message.
By the way, I think the shard ID is not necessary in this query.
Yeah, it is not. So we get the max message sequence number. We add one from mailbox. Where entity ID.
And by the way, if I don't know how to do it, but it might be that this is the first message,
Yeah,
so you cannot rely on the previous to be there.
I will have to. I'll look into it, but in the idea is something like this. Assuming we have other messages, this is the idea, right?
Yeah, which needs to be refined for handling the case where there are no other messages.
That's fine. I can do that. Okay. And then, like, obviously, the insert message request would not have the sequence number, and we can actually just take the envelope in, which is great.
And it is in the return type though.
It is in the return type, yes. Because if we go back to insert, this thing needs to return the message
Or rather,
sequence.
it should be return.
Say that again, Mike?
I mean, it should be in the return. So we need to return the
Yeah,
newly added sequence if we added the message. And instead, if the message was duplicated, we just have to basically do nothing.
yeah, that is the current behavior here. The result of this query could be nothing. I don't exactly know how to do this with effect SQL, but it would probably be something like,
Or it could always be the sequence number and a boolean if the message was new or not. Like,
yeah,
you can play with the thing a little bit, because it's I think for the party who inserts the message, or rather for the party who tells the entity, like this is there is already a difference in telling. If you just tell, then there is nothing to be done. If you are asking, then I have to reply to you with the same reply that I gave you previously. So basically, I don't restart processing. I just then listen to the same to the same result. Because the point of having the message ID is idempotency.
right.
You don't know if you've sent the message or not. You just resend it. But idempotency also means you should get the same response back.
Well, I guess we could, yeah, I'll have to adjust this query because when we actually insert the message, you're right, we probably want the result. Because okay, the entity receives a message that it now needs to persist into storage. The entity attempts to persist the message into storage. When it does that, it calls insert on the message mailbox storage. If the message was already there, we were regardless of whether the message is there or not, we're going to respond back to insert with a particular structure. And that structure needs to indicate to the thing that called insert whether or not the message was already processed, right? And right now in our table, um, the way we indicate if a message was actually processed is whether or not there was a result, right? Because our message acknowledged is just a boolean that for whether or not it was acknowledged. If the message was actually fully processed, then there should be a result. So essentially, the
Well, I
query,
mean, the result might be avoided. But the point is, if it was already inserted, not even acknowledged or processed, there's nothing else to be done. You just have to wait for the response
right?
if the insert wasn't asked. But we don't have to do anything else because the entity is already processing that message. It's
Right.
already in its queue.
So really, it
This
would
is the in-queuing operation. We are not gonna in-queue if it's already there.
right. So in that, like, basically, the response would be a message state where we received the message already.
Yeah, I think it has to answer back with some sort of message state.
Mm-mm.
It's like inserted, acknowledged, or processed.
Yeah, received, acknowledged, or processed, probably.
Some kind of thing like that.
it I think we have like a there's a little bit of a problem with terminology here because technically message state acknowledged is overloaded to both mean like received and acknowledged, but I don't think it should be.
No, I don't think this is the same state.
I think there should be
It's a
another one
different
here
state.
that's like received, which indicates the message was received but not acknowledged. Acknowledged is a separate thing, and then processed is also a separate thing.
And process, it means it has a result.
Right. And the result
Because
would
by
be
the way, a message could be acknowledged, but never has a process.
right. Is the a processed
In
message
and at most once, you first acknowledge, then you process. So you might get to process, but you might fail to process.
right. Um, yeah, I think I need to go back to my old no, received would just be like whether or not there's a value here, something in the mailbox already. I'm just thinking about it from like how do you represent it from a database perspective. Received would be the messages in the mailbox storage here, but not acknowledged, which is when there's a zero here. Acknowledged is a one, and processed is if there's a result.
Received
Sorry,
means it's in the mailbox.
right. And the default for the
But
acknowledged field here is a zero.
also this message state, I don't think it has anything to do with the query that we were talking about, because received is always the initial state and it gives you back the sequence number. But it doesn't tell you if the insert was a new one or not. If it's a new one, you have to dispatch it to the queue of the entity. If it's not a new one, you don't have to do anything. So this is an additional thing which is on the mailbox storage. It's not the message state. It has nothing to do with the message state. It has to do with the insert query.
Right. But okay, so let's say the entity inserts.
Because that's it. You An entity receives a new message. Okay.
Mhm.
First it goes to the storage. It saves the message. The message was new. It directly dispatches it to the internal queue that the behavior will pull from. This is new message. Entity receives a message which was already there, goes to storage, finds that the message already existed, does not put it in the queue that the behavior takes. Otherwise, you're just over dispatching to the behavior
Right.
out of order messages. So if the message was already there, you have to take a different path, which is not dispatching to the internal behavior. It's just listening to the result if it was an ask and just do nothing if it was a tell.
Yeah, I guess we'll have to figure that out from like the client side, but think I'm just thinking about it in terms of like from the entity side for the moment. So I guess you're right. The 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 message state doesn't actually need a received.
I mean, the message state, it's kind of a different thing.
Yeah. Um, no, but this makes sense. That makes sense. Um, so I think I'm tracking on like the insert message, like when the entity inserts a message, if the message was there, then we take a different path. If it wasn't, we store the message and dispatch the message to the mailbox's queue to be processed. Um, do we do we actually dispatch the message directly to the entity's queue, or does the entity pull from mailbox storage? So this is kind of talking about something different, but like when an
It should
entity,
dispatch it right away because the writer to the message storage is the pod.
right,
So the pod can directly dispatch to the behavior. There's no point having the behavior pool every few seconds. It would only slow down the delivery.
right, okay, I think that makes sense. Then,
It's like a push versus pull.
right, right, right.
Having a single writer, we can do a push
Yeah, we just push directly into the mailbox queue that the behavior is reading from.
because we know you have a new message, so it's like go
Right.
on. There's no need to have you pull into 100 milliseconds to figure for new messages. I'm the only one who writes new messages. I know if I have new messages.
Yeah, that makes sense. That makes sense. Um, yeah, I like that more than querying the database repeatedly, which would be like inefficient. Um, the so actually, this actually brings up a point I wanted to ask you about as well, which sort of doesn't really have anything to do with mailbox storage, but does have to do with mailbox state. So if you would indulge me for a moment.
Sure.
Sharding.ts. So sharding is the thing that we discussed earlier, which is responsible for creating messengers and things like that that can actually be used to send messages to pods and entities and things like that, or to entities rather. Um, so you would use sharding to create a messenger, which can then for an entity, which then can be used to send messages to an entity with a particular ID. And I think there's an example in we look at cluster node examples. I think there's an example here where you create a messenger for an entity. So in this case, we create a messenger for the counter entity, and then we use that messenger to basically send messages. Whether I mean the terminology can change, but whether we tell or ask, we can basically send messages to that entity with a messenger. But sharding is what actually creates the messenger in question. So um, what I wanted to ask about is how basically we and I think that Mattia and I were talking about this a little bit in Discord, but um, when we go to send a message via sharding to an entity, how encoding of that message should be performed. So at the moment, what happens is that we encode the message itself, um, and then we store that encoded message in a data type called like a serialized message. and then we pack that into an envelope, which is called, I mean, it's a regular envelope that contains a serialized message, um, and then we call that like a serialized envelope. But I'm really not satisfied with this whole like all these serialized data types. The reason why we go through these hoops, Mattia sort of described in Discord, but the when we send a message, we want the metadata of the envelope available. And if I remember correctly, I can look at our discussion, but where was it that he said that the receiver side of the message uses the serialized data types. But I feel like there's a better way that we can do this. Because if you look, for example, at like what serialized message actually is, it's basically the equivalent of. I mean, I've made a bunch of changes to this, but before I made changes, it was basically this, where the success, the failure, and the payload are all just like strings. And the only reason this data type even exists is because an envelope can only store can only have tagged requests as messages. And if you look, uh, let's go to serialized envelope. It's literally just an envelope that has a serialized message in it. Um, like I want to find a better way to do this because I feel like there's a lot of like indirection happening here that doesn't make a lot of sense. Um,
I mean, shouldn't an envelope be directly serialized always?
it
Because the sender has to serialize the message, and the behavior, the final piece, is in charge of decoding it. So if the envelope is the thing you send, like the letter to your home, then that thing is always serialized. When you open it up, you deserialize the inner.
so you're saying that when the behavior pulls from the, I mean, it's not the responsibility of the user necessarily, but like when the on the receiving end, right? The we send the message is serialized, it goes over the wire. The receiver gets it,
Stored
and
to a database.
right, blah 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 blah.
We have to store to the database the serialized thing. You can't store to the database the non-serialized thing.
Obviously, but the receiver gets it, right? And the mailbox for that entity eventually gets that message. And internally, before it actually calls the behavior, it uses the schema of that like uh of that entity to decode that message. Is like what you're saying.
Yeah, that sounds to me like the only logical
Yeah,
piece.
because to
Is
me, I
the
think that I think that that makes sense. And my thing was like, okay, so let's say that we're going through this messaging protocol, right? So, where is send message? So send message is in send message is what is responsible for actually like coordinating the sending of the message to either the same pod or a different pod. Um, and if we look at this, uh, send message to pod. So basically, this message just sort of decides if it's going to send the message to the local entity manager or to the remote pod. But the like both of these are essentially still receiving an envelope, and like the idea I was talking to Mattia about was that essentially you can take the envelope, serialize it, send it directly over the wire, and then use the mailbox of the entity, not the mailbox storage, to deserialize the message right before it goes to the behavior. And I think Mattia and I were in agreement on that, but I wanted to make sure. from your perspective, it made sense. It sounds like you're suggesting basically the same thing. It's like you serialize it, it goes over the wire, gets stored in the database, blah blah blah
Yeah,
blah.
the point of having this duality of serialized non-serialized was because in shortcake, when messages are not persisted, in theory you can skip serialization altogether if the sender and the receiver are on the same pod,
Got it. Okay.
because then you can share memory. But first, this is a terrible idea because it usually, when you test locally, you have a single process and all your entities are there and
Right.
everything works. Then you deploy and oh fuck, I have a serialization boundary and everything explodes. So
Okay,
not a
so
good idea to skip
that makes sense. What you were saying now,
skip things.
you were saying we treat the message the same regardless of if it's going over the wire or not. We still do the full like encode decode
We
serial.
have to store the messages. So for us, there's no difference. We
Right.
still have to encode the message to store it,
Right.
even if it's on the same pod.
Okay.
Even if if the storage is an in-memory storage for local testing purposes, fine. We still store the serialized thing. The, the interface should be the same.
Okay.
But there's no point cheating if it's only local or not, because this only introduces problems. Like even with it was one of the things that I always hated about Akka. You tested everything locally and everything worked. Now Akka doesn't even have explicit types. It uses reflection to serialize, like this is Java based serialization. So you didn't know anything, then you deployed and quite literally everything bamboozled because you were storing non-serializable information. And locally, I could send a database connection over a message, which I did sometimes. And of course, you can't do that if you have. I can't send you an open database connection over the wire. It would be beautiful if I could. Would have solved a few problems in computer science, but fortunately, that doesn't work.
Well,
So I
yeah,
do prefer to spend like a few milliseconds more, but at least have
right.
safety that I'm actually like it's not gonna break.
I think that makes sense, and, like, I think it makes a whole especially since we have to store the message anyways, we don't really have a choice. So I think, yeah, I think I'm tracking a lot more of, like, the discussion that was being had than I was before. Um, Another question I had,
Yeah, I mean, there's context over context over context over context. Like,
sometimes
I
it's hard
think
to
we've discussed this 100 times with Mattia.
track. Sometimes it does get hard to
It is still a 2-year-old project.
track. Just goes to show there's always improvements to be made, right? Um,
Yeah,
one last question that I had, before, like, I think I've got enough to, like, start trying to incorporate some of this, was the message state. So, when you send a message with a messenger, um, depending on whether you tell or you ask, like, if we just talk about ask for a minute, because asking, I think, is more relevant here, um, you get back a message state from sending the message. And we already looked at the message state before. The message state can be either the message was acknowledged or the message was processed, like from the behavior. Now, I don't know whether or not this makes 100% sense because we again look at like when the actual like usage of this. Um,
I think this is where the thing pulls.
so here, yeah, so ask would be assuming that this is where like if you don't get a processed message state, ask would block until it gets a response, right? Like it would poll.
Yeah, I think we need to revise how this is designed. But I think we should discuss this at a different time because we need to figure better the protocol. Because at the moment it's pulling. It's not very efficient. Mm.
Yeah.
We should probably have an open connection, like an open HTTP connection. We just waits for the message. And if it's acknowledged and you are asking, then you have a conundrum because it means that the behavior has acknowledged but doesn't have a response yet, or will not have a response at all. So in this case, we have to fail.
Right. Yeah, so I mean, I think what probably makes the most sense for the moment is to start working under the like, basically work with the same protocol from the client side in terms of sending messages for the moment. That can be revised as a next step. But I think, like, the next logical place for me to start working is, um, inside sharding, start to, like, adjust the implementation to actually utilize mailbox storage, um, to do things. Because I think there's gonna be additional questions that come up as we start to introduce mailbox storage into the, like, sharding service.
Yeah, I think so.
Alright, cool. Well, this was very, useful.
Cool.
I appreciate your time as always, Mike.
Very fun.
Yeah. Thank you everybody for watching.
Thank you, Hux.